Here we go with number 2. Number 2 says, to increase a owner of a restaurant is running a promotion in which customers' bills can be randomly selected to receive a discount. When a customer's bill is printed, a program in the cash register randomly determines whether the customer will receive a discount. The program was written to generate discounts with a probability of 0.2. That is, giving 20% of the bills a discount in the long run. However, the owner is concerned that the program has a mistake that results in the program not generating the intended long-run proportion of 2. So the owner thinks that maybe it's not 0.2. All right. The owner selected a random sample of bills and found that, look, yeah, only 15% of them received discounts. So then he did a confidence interval for P, the proportion of bills that will receive a discount in the long run, and there is his confidence interval. All right, so calculator out. I go 0.15 plus 0.06 is 0.21. And 0.15 minus 0.06. Even though we can do this in our head, we all tend to do this anyways. 0.09. All right, so he has this confidence interval. And let's see what it asks us to do. Consider the confidence interval. So the 0.09 to 0.21. Does the confidence interval provide convincing statistical evidence that the program is not working as intended? The answer is no, it does not. No. Since 0.20, the desired proportion is within the interval, there is insufficient evidence to say the program is not working as intended. All right, so in terms of justifying your answer, you can't just say no, it's not, but you got to say why. That's why it was key that I said the 0.2 is inside this interval, 0.09 to 0.21. All right, so know the confidence interval includes that value, therefore it's possible to say that it's generating 0.2. All right, number II. Does the confidence interval provide convincing statistical evidence that the program generates the discount with a probability of 0.2? So now they're saying, is the probability 0.2? Slide that out of the way. And II is kind of a fancy way of saying, and this is what I'm thinking in my head, so it's more like a bubble thought over here. The null, if I were doing a hypothesis test, the null would be P equals 0.2. And the alternative, the dude's like, I think it's not 0.2, something's going wrong. So II is asking us, does the confidence interval provide evidence that the program generates the discount with a probability of 0.2? It's saying, is the null true? And you gotta be thinking, oh my gosh, I can never, ever accept the null. So the answer is no. Just because 0.2 is in the interval does not mean the machine is selecting 20%. It could be any proportion between between 9 and 21%. All right. So any value in that interval is a plausible. Is 20% plausible? Yes. Does that mean it is 20%? No, it is not. That's the big caution there for A part II. Moving on. Let's say a second random sample is taken with 4 times the size of the original sample. All right, so we selected 4 times as many. In the second sample, 15% of the bills received a discount. So we ended up with p hat is again equal to 0.15. But now my sample size was 4 times as large. All right. Did I know the sample size from the first one? It says the owner selected a random sample of bills and found that 15% of them received discounts. We know that the margin of error is 0.06, but we do not know how many were in that sample size. So B says, determine the value of the margin of error on the second sample of bills that would be used to compute an interval for P with the same confidence level as that of the original interval. So for B, we've got margin of error. The formula for margin of error is PQ over N, square rooted, and my critical value out in front is Z. So my first interval was 0.06. And now, for my second interval, it said keep things the same, so Z is still the same. And I still have PQ. But now, what do I have? I have a sample that is 4 times larger. All right, so then the question is, well, then what does it end up being? So here's, a little quick algebra manipulation. This is equal to Z times 1, let's go like this. I'm going to distribute that square root a little bit here. PQ, because you can do that when you're multiplying and divided by. So divided by root 4 times root n. So that's equal to Z times root PQ over N, square root of the whole thing, and 1/4, 1/2, because the square root of 2, square root of 4 is 2, and it's in the denominator, so it's here over 2. So really what I've got going on is I've got 1/2 of Z times PQ over N. So what does that mean? That means my new margin of error is equal to 0.03, because that would be 1/2. See, look at that, Z PQ over N. My original Z PQ over N is 0.6. I plug the 0.6 into here. Half of 0.6 is 0.3. So in a proportion problem, quadrupling the sample size with everything else the same makes my margin of error half as big. And the same would hold true for any other type of confidence interval that we're constructing. If, again, assuming everything else stays the same, in this case my p hat stays the same, my sigma stayed the same, or PQ over N, my z-score stayed the same, what changes? The n affects the margin of error. All right, so I'm going to put that over there. And now we go to, based on the margin of error in part B, so that's the 0.03, that was obtained from the second sample, what do you conclude about whether the program is working as intended or not? So now I've got 0.15 plus or minus 0.03. So now I've got 0.12, comma, 0.18. And I would say, since 20% is not in the interval, there is evidence to suggest the cash register is not selecting 20% of the bills for a discount. Period. All right. So the interval does not include 20, therefore there is convincing evidence that the computer program is not working as intended. I've got context in there. I explained how I know and making my answer to that. All right. So that's number 2, parts A, B, and C, of which I am then done. And I ended up doing this one in a grand total of 11 minutes, including a little extra explanations that were going on, which is a good time frame to be looking at. Numbers 1 and 2 in that 10 to 11 minute range or less. All right. Carry on.